Okay, formula mass. We've talked about atomic mass, the mass of one atom, molar mass, the mass of a mole. Now we're going to talk about formula mass. Formula mass is the mass of an individual molecule or of a formula unit. So it's the mass of the formula. Makes sense? It is sometimes called a molecular mass or a molecular weight. And to find the mass of a formula, you just add up the masses of the atoms that are in the formula. Okay? It's like if you had a box with 3 apples and 4 oranges, and you wanted to know how much the fruit weighed. Well, you would just add up the mass of 2 apples and 3 oranges. The whole is the sum of the parts. So let's calculate the formula mass of calcium nitrate. What do we need first? We need the formula. What kind of a compound is calcium nitrate? Is it ionic, molecular, or an acid? It's ionic. We can tell because the first element, calcium, is a metal. So it's an ionic compound. We need the formulas for the 2 ions. So calcium is Ca, and what's the charge on a calcium ion? 2+. We know that because it's in group 2A. Nitrate. What's the formula? NO3, and what's the charge? -1. Why is it that? Because they decided. It's just because. That was a trick question. So to make the formula for calcium nitrate, we need to combine these in a way that causes their charges to add up to 0. You can do the crisscross thing. You can look at it and see the answer. You can look for least common multiple. The result is CaNO3, 2. I need 2 of these to balance the charge on that. Okay. So now I've got the formula. Now we can do the problem, calculate the formula mass. What I'm going to do is I'm going to look up the average atomic mass for each of these elements, and I'm going to multiply them by the number of atoms. So calcium, I have 1 calcium, and the average mass of a calcium atom is 40.08. What would the unit be on that? AMU. We're talking about 1 unit, the mass of 1 atom of calcium, so it would be atomic mass units. How many nitrogens are in the formula? 2, because there's 2 packages of NO3. 2 times the mass of nitrogen. Each nitrogen is an average mass of 14.01 AMUs. How many oxygens? 6. 6 oxygens, 16.00 AMUs. So then you just add those up. 40.08 plus 2 times 14.01 plus 6 times 16. My calculator shows me 164.1 atomic mass units. What about sig figs? Well, you could think about this in different ways. And so I'm not going to get on you too much about the sig figs in atomic masses or in formula masses. So we could think of taking this number and adding this number twice and adding that number 6 times and use the rule for adding, which would say we should have 2 decimal places, right? So then using that idea, we'd have to put a 0 there. If we think about multiplying and adding, we may or may not come up with the same thing. So if we're multiplying, this would have 4 sig figs, this would have 4, and that would have 4. But when we take 16 times 6, 16 times 6, I think it's 40, it's 96. So that one's still going to be okay. That would be 96.00. Sometimes it'll bump up into 100, and so then with sig fig rules, you could get into something funny. So what I would like you to do on your molar masses, or formula masses, we haven't gotten to molar masses yet, never round them, okay? In the problems that we are going to do, your formula mass is not going to limit the number of significant figures in your answer, and you definitely do not want to round it. So if you wrote 164.1 or 164.10, I would be happy with either of those. If you rounded this off and called this 40 and that 14, this is just 16, and just came up with 164 and didn't put any decimal places, I wouldn't like that. Some of them, these are real close to the whole numbers, but some of them, like chlorine, 35.45, is almost halfway between 35 and 36. And so if you round to a whole number, you're going to mess up the mass. So just don't round your masses, okay? Any questions? So that was formula mass. Molar mass of a compound. We talked about molar masses of elements, right? You take the atomic mass on the periodic table, and instead of it being one atom weighs that many atomic mass units, it's 1 mole of those atoms weighs that many grams, right? The molar mass for a compound is analogous in that way to the formula mass. So the formula mass and the molar mass of a compound are the same number, it's just the unit is different. So it's the mass in grams of 1 mole of the molecules or formula units. So what's the molar mass of ammonia? What's the formula for ammonia? NH3. So there's NH3, which is ammonia, and there's NH4 plus, which is ammonium. Ammonia, the molar mass, we're talking about 1 mole of these molecules. So 1 mole of nitrogen would weigh how much? 14.01 grams. And then I have 3 moles of hydrogen, 1.008 grams. And so I get 17.034 grams. That's equal to 1 mole of ammonia. Same process, the unit's different. Because we're not talking about 1 unit, we're talking about a mole of units. Any questions? You could write that grams per mole, yes. So I tend to write it like this, but you can also write it like this, 17.034 grams per mole. And it is a very good conversion factor. Yeah. Okay, so we take the molar mass that we just learned about for a compound and we combine it with Avogadro's number. We can figure out how many molecules or formula units are in a given mass of a compound. So the general idea here is we take grams of our compound A, we convert to moles using the molar mass, and then we convert to the number of molecules using Avogadro's number. So find the number of ibuprofen molecules in a tablet containing 200.0 milligrams of ibuprofen. And there's the formula, because I don't expect you to know the formula for ibuprofen, in part because I don't remember the formula myself. So we read the problem. What number are we given? 200.0 milligrams. What are they asking us for? Number of molecules. So we want number of molecules. This is where I wish we had an abbreviation for molecules.